Here we have another trig functions integrals example problem. So we want to integrate sine 6 of x multiplied by cosine cubed x dx. And our first step in solving this example problem is we want to try and use u substitution. So we notice that the derivative of sine of x is going to be equal to cosine of x, and our sine term is higher than our cosine term. So we'll go ahead and select sine of x for our u, and we can take the derivative to get du, which will be equal to cosine x dx. And so our next step is we want to expand this so that we can define it in terms of u and du. So we can write that as sine 5 of x multiplied by cosine squared x multiply by sine of x and cosine x dx. And we know that this sine of x cosine x dx is our u and du from our u substitution. We can also plug in u to the fifth for sine 5 of x. And our last term that we need to figure out is cosine squared of x. So we need to use some sort of trig identity in order to convert this sine squared of x into terms of u, which is sine of x. So we know that we're looking for, when we look at our trig identities, we're looking for something that links cosine squared of x to sine of x. And so we can look at our trig identities for our Pythagorean identities, and we notice that sine squared, and this theta can be thought of as an x, so sine squared x plus cosine squared x is equal to 1. So here we have our cosine squared x, and here we have a sine of x function. So we can go ahead and rewrite this identity to be cosine squared of x is equal to 1 minus sine squared x by just rearranging the terms. And so now we have our function back in terms of u. So sine of x, sine squared of x is really just going to be u squared. So let's go ahead and rewrite this by plugging in u squared for our cosine, or 1 minus sine squared x for our cosine squared x portion. And we'll get u to the fifth, which was our first term, multiplied by 1 minus u squared, which was our cosine squared of x term, multiplied by u du. Now we can go ahead and factor all of this expression in. We'll get u to the sixth minus u to the eighth du. We can go ahead and do the integral, and we'll get the following expression. And when back substituting our sine of x for u, we'll get our solution to this example problem.